Alright guys, I'm going to make this video about this Hardinge HC Chucker Lathe for everybody out there in YouTube and TikTok land, but specifically for my friend Eric who wants to purchase one of these and just wanted to go through the lathe and kind of talk about the differences between this lathe and kind of a standard manual lathe, because there are some pretty big differences. Eric's got a couple channels. His YouTube channel is Creative Metals by Croxton, and on TikTok he's Croxton Creations. So highly recommend checking both of those channels out. Really talented guy, and a hell of a nice guy at the same time. So check him out. But in the meantime, let's start talking about this lathe. Again, this is the Hardinge HC Chucker. So what I'd like to do is kind of take you through the lathe and kind of show you some of the general specs of the lathe. Then sort of come back and talk about some of the workarounds that you have to do with this lathe as opposed to using a standard kind of manual lathe. And then after that, we'll kind of get into the tooling. So let's get started. All right, let's start talking about the motor compartment here. So this is a 5-horse 3-phase motor, and there's a lead screw right here. You can see this lead screw with a bushing on it. This lead screw turns and moves that bushing up and down and moves the pulley and changes the speeds. They call it a variable speed drive or an infinite speed drive. See, there's a 2-pulley system, and right back there is the brake, the spindle brake. Okay, so now let's open the other cabinet. This is the tooling cabinet on this side. So on my chucker, I have this pull-outs collet rack right here, this swing-out collet rack. And some of these have a drawer that pulls out with a collet rack. There is a spot on mine for another swing-out collet rack. I just don't have it. And this is just a nice place to store your tooling. So this is set up with a collet closer on here right now, and this is a 5C collet closer. This is an 1.1 inch spindle bore on this machine. From the lathe bed to the center of the spindle is 6.5 inches. And again, this is set up with a 5C collet closer right now, but there is this nose spindle is a threaded nose spindle on mine. Some of these have a threaded nose spindle, and others have a broached keyway here. And some of the chucks have a pin that fits inside that broach keyway and will lock in place that way. I think I should probably say that these are also made for very small parts. Again, there's no tailstock, so you can't use a live center here. So these parts that these machines made were typically very short in length. So just to give you an idea. You have about 11 inches from the face of the collet to the front of the tool holder with no tool sticking out. Also remember, if you run a 3-jaw chuck on here, that will make it even further out, making it even a little bit shorter working distance. So this has 3 gears, first, second, and third. Right now it's in first gear, second's in the middle, and then third is all the way forward like that. This is forward, and this lever is forward and reverse. And these are your spindle speeds up here. So on your control box here, we have the master on and off. We have the brake on and off. I always run the brake on. And then when we're looking at speeds, in first gear we have from 125 RPM all the way up to 420 RPM. Second gear is 375 all the way up to 1250. And then in third gear we go from 1050 all the way up to 3000. Right here's the spindle lock. Just pushes in to lock the spindle and then out to release it. So this lathe does have power feed in the Z and the X axes. For the Z feed, it's just controlled back here by this box. So your speed is controlled here, and the direction of the carriage is here. So left is Z minus towards the spindle, and then right is Z positive towards the back of the machine. This is the motor here for the Z axis, or for the X axis, and we do have a coolant pump right here that is connected to the sump. This is a automatically oiling machine, so you pull up on this lever and release it. It slowly sends the oil out in through the entire carriage. These here are your power feed levers. This is the power feed for the Z-axis. This is the power feed for the X-axis. The X-axis analog dial is separations of 15 thousandths. So I actually put the DRO for the X-axis and only the X-axis because these are 15 thousandths, and that math can be cumbersome. The X-axis analog dial is really nice. Hardinge uses this white plastic high-vis material, and nice big numbers here, so no real reason to put a DRO here. There also is another scale here for the X-axis, and Hardinge supplies these clips for this scale and for here. So when you get set up for a job, you can place these clips at different positions to know when you're getting close to when you're going to hit your number. Up here we have the carriage lock right here. This stops the Z travel. And right here we have a bump stop for the X-axis. And we're going to talk more about this as we kind of get into the turret and the tooling. This is a really important stop to have. Speaking of stops, these machines come with these carriage stops here. These are indexable, and there are 8 stations on this stop. So 8 stations on the stop and 8 stations on the turret, so that we can customize each stop on the carriage stop for each tool for the Z-axis. You'll notice as we continue to talk about the chucker here that there's going to be a lot of recurring themes Hardinge seems to use in their design process, such as using 5/8 bushings for these ID holes for their tool holders, and using 3/8 tool holders for the rest of your turning type tools. Hardinge seems to use a lot of levers and stops as opposed to lead screws, and we'll get more into that. So as I said before, this is much different than your standard kind of manual lathe, and the first thing you'll notice is, number one, there's no tailstock here. The turret is the tailstock. So finding the center of the part for me at first was problematic, but I've figured out some workarounds that work for me. There's a couple ways to do it, but I'll show you the way that works best for me. Another thing you're going to notice is that there's no gearbox on this thing. It only has the carriage feed here with speeds, so there's no real way to single point thread traditionally. However, there is a threading attachment right there, and I'll show you how that works as well. So for the first thing, let's talk about how we get around finding the center of the part without a tailstock. So let's figure out how to find the center of any piece that we're trying to find the center of. Again, these tool holders that you see here are very standard for these machines. Again, it's a 5/8 hole. And what I did was I made this tool, which is just essentially just a couple of bushings with a male and female side and a really nice fit. And what I'll do is I'll put the male side in the tool holder, like so. Just provisionally type this down. Okay, and then I will index this to the work position. Okay, so you're going to see that we're pretty close here, and that's just by eyeball, okay? And I have my carriage run all the way in to the stop right there. And now what I'm going to do is I'm going to just loosen the set screw, and then I'm going to loosen this screw to give us the ability to move our carriage, our X-axis, in a little more. And we'll find the center here. And now we're in. Okay. So there's the center. So then I'll come back here And I will make sure that this is snug right up against the stop on the carriage. And snug this one down. Okay. Now we can come back and we can move our x-axis out. And now we don't know where the center is anymore. But because we set our stop, we can find the center. We have the center again. So now let's talk about how we thread on this machine. So again, we don't have a gearbox here. So how do we put threads, ID and OD threads on our parts? This machine comes with this threading attachment. Here's the attachment in the disengaged position. It's basically just pushed back. And to engage it, all we do is pull it forward and the cutting tool, the threading tool is here, will drop onto the workpiece and travel in and cut the threads. We set the thread depth here on for our tool. The number of passes the machine takes is set by this dial back here. And the length of the screw is set by this stop right here. When that pickle fork hits that, stops the machine and moves it back to the beginning of the beginning of the thread. Over here, this is comprised of two pieces. This is a lead screw on the spindle, and this is a follower, okay? So I'm going to push the machine back. I'm going to push the threading attachment back. It takes it away. So when you get, depending on which thread pitch you want, this is set up for a 20. This matches, this is a 20, this is a 20, they match. And when you get good and ready, you drop the threading attachment down, and it comes close, but it doesn't actually touch. It's tough for you guys to see that, but there is clearance between there. When you have everything all set, you will pull this knob and the machine will start. And depending on what you've told it to do, it's going to do. So you can very easily crash this machine if you're not careful. You have to really understand how it works and do many dry runs before you actually try to thread a part. This is what it looks like on the back side. This is pneumatic and electrically controlled. This is the pneumatic breakout box right here. You run it at 75 pounds of pressure. You put oil here, spindle oil, and it oils the device. Let's go ahead and talk about the turret for a minute. This is the fun part, right? So we pull the lever, it advances to the next station, and then locks it in place. There is a way, there are set screws in here so that you can adjust this. So again, you're going to see a lot of recurring patterns with Hardinge and their design process. These are all 5/8 holes for these. So for the turning tools, you're going to use 3/8 inch shank turning tool, whether it's carbide or high-speed steel, whatever. So from the face of the turret to the top of the tool is 3/8 of an inch, which is the center line of the spindle. The typical tool holders that you'll see for this machine, there are these ones, like this one, for example, has a little shelf that comes out and butts up against the face of the turret right here, and those are handy. But they also have ones that can be rotated top of the turret if you want to cut a taper one way or the other. So let's look at some of the turning tool holders. Here's a typical turning tool holder for these machines. This is what it looks like. And again, 3/8 inch shank tooling here. Okay, so now let's start talking about some of the tooling. So these are what is known as Hardinge bushings, drill bushings, or I also use them for boring bar bushings. Right. So I think so most of these are all 5/8 OD, but all different size IDs. So I can put different size drills and the like. Notice there's a flat on all of these. That would go in. Index it in. And now you can run your boring bar in there. All right, so we're just going to look at some more tooling now, and this is what I like to call semi-live tooling. Again, you're going to see some recurring themes here with the Hardinge tooling. They like to use levers and stops. So this is a taper attachment. This would be bolted to the turret, and the boring bar is actuated by this lever. So you can just send the boring bar in and out, and you can get your angle off of your turret with a protractor and set this in to cut a taper. This is a groove-in tool. So this is, again, on a lever, but it's spring-loaded, right? So you can actuate it with this lever, and then back here there's a set screw for a stop, so depending on how deep you wanted your tool to cut, you would set it accordingly. This is another boring bar attachment, and this is just actuated here, so we can take our cuts here instead of moving the x-axis on the carriage, or you could use this as a groove-in tool, again, and just dial in with an analog dial. These would be a kind of a turning tool style holder, and you can see these come in different lengths, shorter, longer. The shorter ones I typically use when I want to get really close to the spindle, parting off or facing, and these are for when I really want to turn something long. A lot of people like these style drill bushings. These are called I think they're called Buckner drill bushings, and they're pretty handy. As you can see, 5-inch shank. These are nice because you can get these a lot closer to center. If your machine runs out in any way, these are a little more adjustable. So those come in handy. We can just have a look at our lead screws and followers. So this is a 12 thread pitch right here. Here's our follower. Here's our lead screw. And they're all marked as such. And yeah, they just run together. And that's how you cut your thread pitch. This is what dictates your thread pitch on your threading attachment. This is mobile vector 2 oil, and that's what they're requiring here for the oiler for the ways. So you want to make sure you get that. And for the power feeds for the lead screws, they're calling for automatic transmission fluid type A or equal. So you want to make sure that you get that for there. And there's the fill there, and the sight glass is down right there. You want to fill it about halfway. So this is the electrical box for the lathe. Truly, it's a spider web in there of wires. Never open this box unless you absolutely have to. As I mentioned before, this machine does have a coolant pump, and this is the spigot for the coolant pump right here. And never run water-based coolant in these machines, always run cutting oil. There is a 5-gallon sump in this machine, and right here is here in the chip tray is the screen, and again, 5-gallon sump down in there. Oil drains back in and then repumps out. Okay, so let's go ahead and run the machine a little bit. Let's go put it in third gear. And that starts the spindle. And right now I'm running at 1550. I'm going to bump it down. All right. Let's move the power feed on the cross slide. So I'm just going to go ahead right now. I'm set for Z minus. So I'm going to go ahead and engage. And again, we can control the speed by turning here. Okay. Now let's go ahead and turn the other direction. And now we just back up. So now let's go ahead and try the power feed in the Z-axis. Right now we're feeding out. Now we'll feed in. You can run these simultaneously. So let's come in and get ready to face this off. I'm just going to come in and touch. Right there. So easily, I can literally turn it with just one finger if I want to. Like I said, very different than a standard or traditional lathe. Does have its limitations. I will say that these machines were what people were using for production right before CNC took over the world. So these machines are designed to make many of the same part with the same features over and over and over again. These are actually what's known by many people as a second op lathe. So the first op would be done on like a bar feed machine where they would rough it out or, you know, cut the blank, get its size. Then you bring it over here and put all the critical dimensions in. And again, they're designed to do multiple parts, so like small, multiple production run parts. So Eric, I hope this helps you out, buddy, with your decision, or anyone else for that matter that may be interested in getting one of these or is just basically interested in how they work. Again, they're a little different than most, but pretty cool.